Welcome to Spaceverse, your portal to cosmic adventures. In the vast theater of space, where stars are born, evolve, and die, the universe has once again whispered a secret, and this time the James Webb Space Telescope was listening. Recent discoveries made possible by NASA's James Webb Space Telescope, or JWST, have reshaped what we know about planetary survival, even in the face of stellar death. In a groundbreaking observation, astronomers have confirmed the existence of a frigid world orbiting a dead star, a white dwarf, named WD 1856 plus 534. This exoplanet, designated WD 1856 plus 534b, has now officially become the coldest exoplanet ever directly observed. It is a gas giant, roughly the size of Jupiter, located around 80 light-years from Earth, and it completes a full orbit around its stellar corpse every 1.4 days. Let that sink in. A massive world racing around a dead sun every 33 hours. Dr. Mary Ann Limbach, an astronomer at the University of Michigan and lead author of the new study, shared her astonishment with Space.com, saying, quote, "We were all a bit surprised and excited to find that it was, in fact, a planet, and a really cold one at that." Back in 2020, astronomers had spotted this curious object using the now-retired Spitzer Space Telescope. But with its limited infrared sensitivity, they couldn't tell if it was a planet or a brown dwarf, those mysterious failed stars that blur the line between planet and star. But thanks to the James Webb Space Telescope's advanced infrared instruments, scientists have now captured the planet's own light, and with it, its mass, temperature, and fate. And here's where it gets even more astonishing. This planet is orbiting well within what scientists call the Forbidden Zone, a region around a white dwarf where, theoretically, no planet should have survived. During its red giant phase, this star would have swelled to many times its original size, potentially engulfing everything in close orbit. And yet, here lies WD 1856 plus 534b circling undisturbed. Not only did it survive, it migrated inward. Dr. Limbach explains, "This is compelling evidence that planets can not only survive the violent death of their star, but also move into orbits where we didn't necessarily expect them to exist. This discovery doesn't just rewrite our theories on planetary evolution. It opens a door to new possibilities. If planets can settle into new orbits around dead stars, then perhaps, just perhaps, they can migrate into habitable zones. Zones where liquid water could exist, where life, in some distant form, might emerge or persist. In the dark silence of space, where light from stars can take centuries to reach us, the James Webb Space Telescope has cast its eye on a realm of unimaginable cold. A place not of fiery suns or blazing nebulae, but of planetary ghosts, frozen worlds, and stars that have already died. And in that darkness, it found something extraordinary. This is the story of WD 1856 plus 534b, the coldest exoplanet ever directly observed, and how this single discovery is redefining everything we thought we knew about planetary survival, migration, and the hidden afterlife of solar systems. Let's begin with a record. Until recently, the coldest directly imaged exoplanet was Epsilon Indiae b, a gas giant similar in size to Jupiter. It orbited its host star at a frosty 35 degrees Fahrenheit, or 2 degrees Celsius. Cold by human standards, sure, but still relatively balmy in galactic terms. Then came WD 1856 plus 534b. Using the cutting-edge instruments aboard the James Webb Space Telescope, astronomers detected a world orbiting a white dwarf, the smoldering core of a once-living star, at an astonishingly low temperature of minus 125 degrees Fahrenheit. That's minus 87 degrees Celsius. A frozen giant locked in an orbit so close to a dead star that scientists had once considered its existence impossible. So how does a world like this survive? What does it tell us about our own solar system's destiny? And just how cold can planets really get? Let's dive deeper. WD 1856 plus 534b is a Jupiter-sized exoplanet located about 80 light-years from Earth. It completes a full orbit around its white dwarf star in just 1.4 Earth days. That's roughly 33 hours, an incredibly short period for a planet of its size. Imagine a massive gas giant orbiting so tightly around a star that's no larger than Earth itself. The image is surreal. But here's where things get even stranger. This planet isn't orbiting an ordinary star. White dwarfs are what remain after stars like our Sun exhaust their nuclear fuel. During the red giant phase, they expand dramatically, swallowing nearby planets, vaporizing or ejecting others, and eventually shedding their outer layers to become dense, hot stellar cores. In this destructive phase, any planet that wandered too close would have been obliterated. And yet, WD 1856 plus 534b survived. More than that, it ended up in the so-called Forbidden Zone, a region so close to a white dwarf that its very presence challenges our understanding of planetary dynamics. How did it get there? Did it migrate inward after the star died? Was it flung into its current orbit by the gravity of another planet? We don't know yet, but we're starting to piece it together. According to Dr. Mary Ann Limbach, an astronomer at the University of Michigan and lead researcher on the project, this discovery is opening an entirely new chapter in exoplanet science. This is a significant improvement, she remarked. It's a rare opportunity to place our own solar system in a broader galactic context, and the search is far from over. Upcoming James Webb Space Telescope programs are aiming even higher, or perhaps we should say, colder. Scientists believe JWST could one day detect planets as frigid as -324.67 degrees Fahrenheit, that's -198.15 degrees Celsius. Nearly the temperature of liquid nitrogen. A cosmic deep freeze. These next-generation observations may allow us to finally study exoplanets that are truly similar to Jupiter and Saturn, not just in size, but in age, mass, and temperature. Imagine looking at a world that resembles our own gas giants, except orbiting a star light years away. Or perhaps orbiting no star at all, drifting through the galaxy in frozen solitude. For astronomers, this is a thrilling frontier. But the mystery of WD 1856 plus 534b continues. This July, Dr. Limbach and her team will return to the system for a second JWST observation, exactly 1 year after the first. Their goal? To compare the position of the planet and its white dwarf to background stars. By detecting subtle shifts in the planet's motion, they hope to uncover signs of other planets hiding in the system, companions that could be influencing its orbit through gravitational interaction. If another planet is found, it could provide the missing link. A second, more distant planet may have acted as a kind of cosmic slingshot, pushing WD 1856 plus 534b into its current position after the white dwarf's violent transformation. This would help explain how a gas giant could migrate inward without being destroyed, a phenomenon that could apply to other systems across the galaxy. But even if no other planets are detected, the follow-up data will still offer valuable clues. It will help astronomers test competing theories about how gas giants end up orbiting so close to white dwarfs. Was it slow tidal migration over eons? A sudden gravitational encounter? Or something entirely unexpected? Each new data point helps refine our models and brings us closer to understanding the long-term fate of planets after their stars die. And that brings us back home. One day, billions of years from now, our own sun will follow the same path. It will expand into a red giant, potentially consuming Mercury, Venus, and maybe even Earth. Eventually, it will collapse into a white dwarf, a glowing ember of its former self. What will happen to Jupiter? Saturn? The icy moons and dwarf planets at the edge of our system? Will they be flung into deep space? Pulled inward? Could they end up like WD 1856 plus 534b, orbiting closely around the burnt-out core of the star that once gave them life? We don't yet have the answers. But with each passing month, with every new JWST observation, we get a little closer to understanding not just the fate of alien worlds, but the future of our own. So when we look at this frozen planet, this silent, drifting world clinging to a dead star, we are not just looking at something strange and distant. We are looking at a future we may one day share. Thanks to the James Webb Space Telescope, the afterlife of stars and the resilience of planets is no longer just theory. It's observation. It's data. It's real. Stay tuned. Because in the coldest corners of the universe, the story of life, death, and cosmic survival is just beginning to unfold. And we're here to witness it. Thanks for joining us here on Spaceverse, your gateway to the mysteries of the cosmos. If you enjoyed this deep dive into the universe's coldest worlds and stellar secrets, don't forget to hit that like button, subscribe, and ring the bell so you never miss an adventure beyond the stars.